Hey guys, Professor Doney back again with another installment of some physics problem solving here. In this next one we're going vertical. We've already talked about horizontal motion and now we're going to go vertical. And the way we do that is really just change things up here. We're going to look at vertical problems in the coming videos where we go up, things that come down, or things that go up and obviously come back down if they don't go high enough. So we're going to look at those different options, how we apply those. But let's look at the equation we start out with. Now, originally we're in the horizontal direction. We had a couple equations we used. V equals VO plus AT, VO squared plus 2A delta x. And delta x, or displacement, is initial velocity times time plus half acceleration times squared. And those were, that's what we used to go horizontal. We used initial velocity as VO and final velocity as just V, and time, acceleration, all that. Now we go vertical. We're going to call that the Y direction. And we have to adjust these equations a little bit for our use when we go vertical. Now what we're going to do is everywhere we say A, we're going to replace it with G. Why? Because vertically, if things are in free fall, meaning not being pushed down or pulled up, gravity is what accelerates it towards the ground. The force of gravity causes it to accelerate towards the ground. Or if it's moving away from the ground, gravity, which is acting in the opposite direction, causes it to decelerate. But it's always at that constant rate, and that rate is equal to 9.81 or 9.8 meters per second squared if we're close to the, for all the problems we're going to do anything close to the Earth. Now since we're going from X to Y, we're going to switch all our X's to Y's. And what that's going to allow us to do is now rewrite our equations to be for the vertical. We're going vertical. So our first equation is V equals VO plus GT. Our second equation will be V squared equals VO squared plus 2G delta Y. Our last equation is delta Y VOT half G T squared. And those will now be the three equations we use when we go vertical. They're essentially the exact same equations you there. We're just changing the variables a little bit so we can identify that, yeah, Y, that means vertical, and G means gravity. Okay? So those are the three equations we're going to use. We're going to solve things the same way. Now the book may put, or the text you're using may put little sub Y's in here, VO sub Y or V sub Y, and they may put of X's over on this side for horizontal, just to remind us what direction we're going. But when we go vertical, we're going to know we're going vertical. And what we need to keep in mind is that our acceleration to Y direction is equal to gravity, which is 9.1 meters per second squared, and that's always going to be down. Now again, that 9.81 meters per second means it's going to increase the speed 9.1 meters per second every 1 second by 9.8. So after 1 second we're doing 9.81 meters per second. After 2 seconds, twice that, which is what, 1962 or something like that. 3 seconds, 3 times that, etc. So that sort of sets us up to go vertical. Now, depending on which direction we're going, will determine whether gravity is positive in these equations or whether gravity is negative. And that's what we're going to talk about in the next video that talks about drop problems, throw down problems, throw up and come back down problems, and discuss a little bit how the book solves that. So hopefully that gets you started understanding why we go vertical and we change the equation just a little bit. So we'll see you next video.